Welcome to today's mathematics class where we'll talk about indices. An indices is a plural form of the word index. Indices can also be called exponents or powers, and they are mass notation used to represent repeated multiplication of numbers by itself. They are written as superscript number that represent how many times the base number should be multiplied. Let's say, for example, if a number a is multiplied by the same number a severally, the indices will be a raised to power the total numbers of multiplication 1, 2, 3, 4, which is 4. And in indices, this number is known as the base number. While the power 4, we call it index or power. And there are laws governing indices. We have several laws governing indices. One is multiplication law. And what is multiplication law? When numbers with equal base are being multiplied, their power, which is the indices, are added. Let's see 1. Multiplication law. Let's say, for example, a number a raised to power m times the same number raised to power n, it will now be a raised to power n plus n. And remember, before this law can be applied to our indices, the base number must be the same. And also, we have the second law. The second law, which is division or content law. And when dividing numbers with equal base, the power of the divisor is subtracted from the power of the divided. Let's say a number or content law. If a number that is raised to power n is divided by a number that is raised to power n, their power are subtracted. And that is that for division or quotient law. And the third law, we call it the power law. If a number which is raised to a power is again raised to another power, their power are multiplied. Let's say the law, which is the power law. Let's say a base number s is raised to power a and again raised to power b, it will now be s raised to power a times b. This is for power law. And the fourth law, we call it the product power law. This is where the product of different numbers are raised to a certain power. Perhaps in a bracket, that power is distributed over each base number. Let's say for product power law, we have a base number s and y, and it's raised to power 2. This power 2 is distributed over the numbers that are in brackets. It now be s squared times y squared. This is what we call the product power law. The fifth law is the fractional index. This is where a number is raised to a power which is in fraction. We have 5. Rational index. If a base number 8 is raised to power 2 over 3, this will be written as the denominator, which is 3, root the base number 8, or raised to power the numerator, which is 2. But there is a way of representing it. I call the denominator the rest. That is, it rests at the back of the root, while the numerator the power. That is, everything raised to power the numerator. This is a way of representing it. Let's use another example. If I should have 27 raised to power 2 all over 3, the denominator, which is the rest, and of the base raised to power the numerator, which is 2. This is the cube root of 27. It simply means that which number can be multiplied 3 times that will give you 27. It will now be equals to 3 raised to power 2, which is 9. This is the fractional indices. Let's consider the 6th law, which is the negative indices. Negative index represents the reciprocal of a given index. Law 6, which is negative index. Let's say a number a, or a base number a raised to power minus 2. To remove this negative sign, we use the index to divide 1, which will now be 1 all over a square. This is for negative index. And the last one is 0 index. In 0 index, any base number that is raised to power 0 is equals to 1. It can be an alphabet or a number is equals to 1. We have the 7th law, which is 0 index. The number, let's say a raised to power 0 is equals to 1, or 16 raised to power 0 is equals to 1, or s raised to power 0 is equals to 1. These are the law governing indices, and they can be used interchangeably. And the most important law of indices are multiplication and divisions. All other laws are used to simplify the indices so that we can use the multiplication or the division law. So let's solve some example on indices.
Let's solve this question using the laws of indices. Since 64 raised to fractional index of 2 over 3. If you look at this question, you know that this is a fractional index. In solving this question, it will now be the rest, which is the denominator, root the base number 64, or raised to power the numerator, which is equals to cube root of 64 will now be 4 raised to power 2, which is equals to 16. This is our answer. This is our answer for question 1. Then look at question 2. We have 4 raised to power minus 3 over 2. And this is both fractional index and also negative index. Firstly, we remove the negative, now be equals to now the 1 divided by the indices, which is 4 raised to the power 3 over 2, which is equals to 1 all over. Since the denominator is 2, it will now be square root of all raised to the power 3, which is equals to 1 all over 2 raised to the power 3, which is 1 all over 8. This is our answer for question 2. Let's consider the one of question 3. Question 3. We have 64 over 27 raised to the power minus 2 over 3. This is both fractional index and also negative index. So the first thing to do is to remove the negative, which is the negative index. Now be 1 divided by the indices, which is equals to 1 divided by 64 over 27 raised to the power 2 over 3, which can be written as 1 over the rest, which is the denominator, 3 bracket 64 over 27 raised to the power 2 all over raised to the power 2. And this, you can find the cube root of 64 is 4 over the cube root of 27 is 3 all square, which is equals to 1 over 16 over 9. And this can also be written as 1 all over 16 times 9 all over 1, which is 9 over 16. That is answer for question 3. Let's consider question 4. Question 4. We have 3a squared times bracket 5a close bracket is power minus 2. With this now, use the power product to open this bracket. It will now be 3a squared times 5 raised to the power minus 2 times a raised to the power minus 2. And you can see we have the same base here, 3a and a. This you can use multiplication law to add them together. It will now be 3a 2 plus minus 2 times 5 raised to the power minus 2, which is equals to 3a 0 times 5 raised to the power minus 2. Now you can remove the negative from this power 2, which is equals to 3 times 1 times 1 all over 5 raised to the power 2. Therefore, 3 times 1 will now be 3 over 5 squared, which is 3 over 25. This is our answer for question 4. So let's solve the one of question 5. We have 9 raised to the power minus 1 over 2 all over 27 raised to the power 2 all over 3. Also be written as 9 raised to the power minus 1 over 2 times 1 all over 27 raised to the power 2 over 3. And to remove this negative, it will now be 1 divided by 9 raised to the power 1 over 2 times 1 all over 27 raised to the power 2 all over 3. And this will now be 1 all over the denominator, which is the rest, 6 is 2 will now be root 9 raised to power 1, which is the numerator, times 1 all over the rest, which is the denominator, of 27 all raised to power 2. We can now have 1 over square root of 9 is 3 times 1 over the cube root of 27 is 3 raised to power 2. From there, we can have 1 all over 3 times 3 squared. Now have 27. That is our answer for question 5. So, question 6. We have 0.027 all raised to power minus 1 over 3. From this question, for us to find the answer to these indices, we have to convert this base to a fraction. From this question, we have to convert the base to a fraction, after which we can convert back to decimal base. To convert it, it will now be the value which is equals to 27 over the numbers of decimal place, which is 1, 2, 3, that will be 1,000 all over minus 1 over 3. Now, we have to remove this negative, which will now be 1 divided by 27 over 1,000 all over 1 all over 3. So now the 1 all over the rest 3 of 27 over 1,000 all raised to power numerator, which is equals to 1 all over the cube root of 27 will now be 3 over the cube root of 1,000 10 all over 1. There, please can also be written as 1 all over 3 times 10 over 1, which is 10 divided by 3, which is our answer. Or 10 divided by 3, we have 3.33. That is for question 6. Let's solve more questions on indices.
Let's look at this question. Simplify 5 raised to power s times 25 raised to power s minus 1 divided by 125 raised to power s plus 1. If you look at this question now, you know that the simplest base is 5. And 5 squared can give you 25. Also, 5 raised to power 3 can give you 125. So the best way to solve this question is to rewrite this base to the simplest form. So the question will now be 5 raised to power s times 5 raised to power 2 raised to power s minus 1 over 5 raised to power 3 raised to power s plus 1. So the question will now be 5 raised to power s times 5, 2 times 2s will now be 2s minus 2 times minus 1 will now be 2 divided by 5, 3 times s will now be 3s plus 3 times 1 will now be 3. And from here now, we can reverse the division law to multiplication law. And the way of doing it is by writing out the reciprocal of the denominator. That is, it will now be 5s times 5 raised to power 2s minus 2 times 1 all over 5 raised to power 3s plus 3. So, from this reciprocal, we can change it to negative index. It will now be 5s times 5 raised to power 2s minus 2 times 5 minus the power 3s plus 3, which is equals to 5s times 5 2s minus 2 times 5 minus times 3s now be minus 3s, then minus times plus 3 now be minus 3. So from here now, we have changed it to multiplication law. So and in multiplication law, we say that if they have the same basis, their power are added. So it now be equals to 5s plus 2s minus 2 plus bracket minus 3s minus 3, which will now be 5s plus 2s minus 2 minus 3s minus 3. This plus this is equals to 5 will now have 3s minus 3s minus 2 minus 3. So this minus this become 1. Minus 2 minus 3 will now be minus 5. So the answer will now be 5 raised to the power minus 5. This is our answer for this question. So let's look at another questions. Let's look at these two questions. Question 1 said that we should simplify 1 all over q raised to the power minus 4k over 3 times q raised to the power minus k over 3. Now be 1 all over q minus 4k over 3 times q minus k over 3. From this question, you will notice that the two bases are the same. So the best way is to reverse this reciprocal to negative index. It will now be q minus bracket minus 4k over 3 times q raised to the power minus k over 3. So this times this will now be positive. Will now be q 4k over 3 times q minus k over 3. And from here now, we can use the multiplication law. We see that when two bases are the same, you add their index or their power. It now be q is equals to 4k over 3 plus minus k over 3, which is q 4k over 3 minus k over 3. Now be q, the numerator, now be 4 minus k, which is 3k over 3. 3 cancel 3. The answer now be q raised to the power k. This is our answer for question 1. Let's consider question 2. We have 2 raised to the power 2s all over raised to the power 3 times 3 raised to the power 3s raised to the power again 2 all over 6 raised to the power 6s. From this question, we have 2 as a base, we also have 3. And 6, you can find the factors of 6, which is 2 times 3, will give you 6. So the question will now become 2 raised to the power 2s raised to the power 3 times 3 raised to the power 3s raised to the power 2 divided by 2 times 3 raised to the power 6s. From here now, we have the power law. the power law, which is a base raised to a power and again raised to another power. And here we have the product power law. This is different base raised to the same power, which can be distributed to the different bases, which will now be equals to 2 this times this, which is 6s, times we have 3 times 2, which is 6s, over distributing this 6 to this 2 will now be 2 6s, times to this base will now be 3 6s. Therefore, this cancel this cancel this, our answer now be 1. This is for question 2. Let's look at the last question. So, let's look at this question. We have simplify 6 raised to the power 2n plus 1 times 9 raised to the power n times 4 raised to the power 2n divided by 18 raised to the power n times 2 raised to the power n times 12 raised to the power 2n. From this question now, know that we can simplify this by writing 2 times 3, and here 3 square, and here 2 square, and this 2 times 3 square, and also this 3 times 2 square. So the question will now be 2 times 3 raised to the power 2n plus 1 times 3 raised to the power 2 raised to the power n times 2 raised to the power 2 raised to the power 2n divided by 2 times 3 raised to the power 2 raised to the power n times 2n times 2 raised to the power 2 times 3 all raised to the power 2n. Because from here now, 2 times 3 will give you 6. 3 square will give you 9. 2 square will give you 4. 2 times 3 square, which is 9, will give you 18. 2n is the same thing. Then 2 square, which is 4 times 3, will give you 12. This is a way of simplifying it. And from the product power law, this can be distributed to the base in the brackets, and also this is a power law. So we have, it now be 2 raised to the power 2n plus 1 times 3 raised to the power 2n plus 1 times, this is a product law, 2 times n will now be 3 raised to the power 2n times, this is a product law, we have 2 times 2n will now be 4n divided by, we have distribute this to this, now 2n times 2 times n will now be 3 raised to the power 2n times 2n times 2, this power times this 2n will now have 2 raised to the power 4n times the 3 raised to the power 2n. From here now, we can cancel the same base that has the same power on the numerator and denominator. If you look at here now, we have 3n here, can cancel 3n here. We have 2 raised to the power 4n, 2 to the power 4n can cancel 2 raised to the power 4n. So the question will now be 2 raised to the power 2n plus 1 times 3 raised to the power 2n plus 1 divided by 2n times 2n times 3 raised to the power 2n. From here now, we said we have 2 raised to the power 2n plus 1, and this can be reversed to product law, which will now be 2 raised to the power 2n times 2 raised to the power 1 This can also be converted to product law times 3 raised to power 2n times 3 raised to power 1 divided by this product law can be added together, now be 2 raised to power 2n times 3 raised to power 2n. From here now, this can cancel this can cancel this. Therefore, 2 raised to power 1 is 2 times 3 raised to power 3 is 3. Now be 2 times 3, which is equals to 6. This is our answer for this question.